Hello friends, today I'm here with a new lecture on ANSYS APDL software in which we will do the analysis of a bracket. There is a given bracket whose young modulus they have given 200 gigapascal, density is 760 kg per meter cube, Poisson ratio it is given 0.3 and the load thickness is given 20 mm of the bracket. This thickness, okay, they are talking about this thickness they have given 20 mm, okay, this one, okay, and a load is applied at the center of the circle towards the minus if this is x and y, so load is applied in minus y direction. In minus y direction load is applied having magnitude 1000 newton. Okay, so this is the dimension of our bracket. There is a circular hole of 60 mm and a small hole of 20 mm, and a meshing edge length they have given, meshing edge length they have given 2 mm. Okay, and this structure will be analyzed using triangular element in ANSYS APDL software. Okay, so without further waiting, let's go to ANSYS APDL software and we will analyze this bracket. So we will go to ANSYS APDL software now and we will analyze this bracket. Okay, so click on the ANSYS APDL software, open in your desktop or in your system. Now we will assign the title for this project or for this bracket, whatever you are doing. Okay, so let's go to file, change title. We'll write the title as bracket. Okay, after clicking OK, click on the preprocessor, go to modeling because we will make our model first, then we will analyze, then we will do the analysis. Okay, click on the create button icon, and after create, go to rectangle area, rectangle by two corner, and assign the values with reference. This is the reference point. For x we will give 0 reference point. For y 0 comma 0 we will start from the coordinate center point. Okay, and width of the rectangle we will give as 80 and 100. Okay, this will be our base rectangle which we will create. On this we will create our main bracket. Now click on the circle, go to solid circle, assign the value for the circle, first circle. With respect to y, with respect to x, we'll give the value as 80, then 50 in respect to y, and radius will give as 50. Okay, click on the apply. This will create a circle having radius 50 and touching this edge point of 2, because this was the coordinate 0 comma 0 and we have given the values. This one was 80 and this one was, means length was 80, breadth was 100. Okay, or we can consider this is the length or this is the breadth, so 100 and 80. So we gave the corner point of the, because we are creating here solid circle using 2 points and a center of radius. Okay, and then we are giving two corner point, that is this is 80 comma 0 and this is 80 comma 100, and center radius we are giving as our radius was, see this is 100, right? So radius will be how much? 50. So radius we gave 50, x value we gave 80, and y value we gave 100. Okay, so now next we will give assign two more circles having coordinate at 0 comma, having 0 with respect to 0 20, we'll 0 comma 20, we'll go to the point 0 comma 20 and we'll make a circle of radius 20. Okay, click on the apply button. Okay, so here we have created a circle. We can see here there is a circle having coordinate point at 0 comma 20. This is the 0, this is the coordinate axis. We can see x comma y, this is 0 comma 0, so this is 0 comma 20 on the, here it will lie, and we are giving the radius as 20. So we have created a circle. Okay, now again we will create one more circle here giving the coordinate point and the center point. Okay, so coordinate point we are giving 20, 0, because it is lie, this point will be lie, the center point of this circle will lie on the y-axis, so x coordinate will be 0 and y coordinate we will give as 80, and radius we will give as 20. as same as the earlier circle what we gave. Okay, now click on the OK button. So here we have created two circles having radius 20, and here we have created one bigger circle having radius 50. This edge length was 100, this edge length was 80. Okay, now we'll go further and we'll create one more rectangle. Click on the rectangle by two corner. We will assign the value of reference point. We'll go to minus 20 comma 20 minus 20 comma 20. We will go to point. We'll go to this point and we will make a rectangle having width 20 and height 60. I will tell you why we are making this one, because we are making this to fill the gap between the two circles. This is the, here is the gap, right? There is a gap between these two circles. To fill this gap, we are going to point minus 20 comma 20. So this is coordinate axis, right? 0 comma 0. Now we will go to point minus 20 comma 20. Minus 20 means in x-axis minus 20. This is the circle of radius 20, right? So minus 20 will come here, somewhere here. Here it will come, right? Minus 20, and in y direction plus 20. This is plus 20. Okay, so it will come here somewhere. Here it will come. So we'll click on the OK button, so it will fill with a rectangle, right? Now we'll move further. Okay, now minimize all this. Now minimize all this area. Okay, now we will go to operate. In order to add all this, we'll add, like we will do the boolean operation to add all this structure, all this circle, this small circle, and this rectangle to add with the base rectangle, right? So we'll perform boolean operation. Now click on the add button. Boolean, go to on boolean, click on operate, click on the boolean, then add, and then area, and we will pick all, means we will add everything. We'll add everything. So we added everything, all these circles we have added, right? All this circle, bigger circle, smaller circle, and this rectangle which we have created to fill the gap between the two circles, all we have added with the base material, so it is attached. Okay, we have performed add operations. Okay, why we have selected area? Because we are making this one in two dimensional. This is a area. If we will make in the one dimensional, then it will be a line. Okay, but here we are making in a two dimensional, so it is, we are making area. If we will perform this same operation in three dimensional, it will be select volume operation. Okay, now again go to modeling, create, again area, minimize this one boolean, again go to create, go to area, go to circle, then go to solid circle, then assign the value and make a circle with reference point of x will be 80, comma 50, comma 50, comma with radius 30. We are giving the radius as 30. Okay, radius 30. Now click on the apply button. So we can see that we have created a circle here. Okay, this was our this circle. See this circle with a diameter 60. We have created now this outer area. Okay, this outer area we have created. See this one, this outer area we have created. Okay, after creating, we will create this hole, and this hole, having this one having radius 30, this one radius 10, and this one radius 10. So we'll make three holes. Okay, first we'll make three circles. After making three circles, we will perform subtract option. This subtract option will remove the area part from here, from this base material. From base material, it will remove the area part, and it will make this bracket. Okay, so let's perform this operation. Again, for the second two circles, we will go to coordinate point, whose coordinate will be, first circle coordinate will be 0, and y value will be 20, and radius we are giving as 10. Okay, click on apply button. Again, see this circle we have created of radius 10. Again, one more circle we will create it here, because we want to subtract this and we want to make a bracket which was the required shape of our. Okay, so let's give the coordinate point of this. So it will be 0, 80, and having radius 10. So we'll go to point 0 comma 80. 0 comma 80, this is the x-axis, this is the y-axis, right? On the y-axis we are taking coordinate point 0 comma 80. So this is 0 comma 0, and on the y-axis 0 comma 80 point will be there somewhere here it will be 0 comma 80, and we are giving the radius as 10, and we are creating the circle. Now we will click on the OK button, so circle will be created. Again we will perform the boolean operation. Again we will perform the boolean operation. In that we will perform subtract and add option to remove the material and make a circle. Okay, so go to operate option, minimize area, minimize create, go to operate, click on the boolean. On the boolean, click on the, see if we want to add, then we'll add first material. Okay, first we'll add, click on the area, click on the area, and first we will add everything. Okay, so we will select all this. Okay, now click on the OK. Okay, this one close. Okay, see, first we made that all three circles part. Okay, then we will go to subtract option. Okay, and this one we will cancel it, and we'll go to subtract option, area, subtract area, what we want to subtract. Okay, this one, this one, this one. Okay, now okay, cancel. Okay, go to add option, click on area. See, first we have created a bigger circle to a smaller circle. Okay, now after we will go to create option, operate, then boolean operation in order to create, and then we'll create on add, subtract, and we'll create on the area. After clicking on the area, we'll click the full volume in the subtract option. In the subtract option, see, not add option, we want to subtract, right? We want to subtract this two circles from the base plate. Okay, base plate area. So we'll click on the subtract area, click on the full material. Then after clicking on the full material, see, we have taken subtract option, right? After subtracting option, click on the area, click the full volume material, and click on the OK. After OK, again it will ask the options to subtract, because one part is subtracted. Again one part is left to subtract, because there was a two layer. Okay, now in this part we will select all this circles, because we want to make the hole here. Okay, now click on OK. So it will make the two holes, total three holes, having two holes having diameter 20 20, and one bigger one having diameter 60. So we will click on the OK, so it will make holes. So here is our required model. This is our required model of one bigger hole of diameter 60 and two smaller holes of diameter 20 20. Okay, now what is remaining? We are remaining to apply the load P at the center point and do the meshing. Okay, so first we'll do the meshing and we'll apply the load. Okay, so let's go to our software and we'll do the meshing and we'll apply the load. Okay, now minimize all this, minimize, operate, minimize this boolean, minimize, operate, minimize modeling. Okay, now we will click on the element type. We will create the element. Okay, click on the element type, add. Okay, add this one. After this we'll click on the add, and we'll get this one library of element types we'll get. Okay, after clicking on the library of, we will choose it here solid, because we want to make a solid one. Okay, we'll click on solid. In solid there is an option called 8 node 183. We'll click on this, and we'll click on apply button, or after that we can click on OK button also, there's no issue. Okay, after that go to option, assign the value. This is, see, in our case we are not using only plane stress, we are using plane stress with respect to thickness. Okay, so we'll select this option, plane stress with respect to thickness, and we will click on the OK button. Okay, click on the OK. Now close this one. After closing, see, we have given the element. Now go to real constant in order to give the constant values. Now go to add. OK, on the this thickness they are asking, what is the asking their thickness, what thickness we have taken, for the bracket thickness was 20 mm. Okay, so we will assign the value as 20. One second. I think it has stopped working. Okay, so we'll give the value here thickness, we will assign it as 20. Okay, we'll click on OK button. We gave the thickness as 20. Okay, after this we'll close this one. Okay, there was some error in the software was stucking. Okay, now we will assign the material properties. We'll go to material model and we'll assign the material properties. Okay, material models, go to structural, linear, elastic, isotropic, and we'll assign this ex means it is asking the young modulus value, and prxy means it is asking the Poisson ratio value. Young modulus value was 200 GPa. 200 GPa will be converted into Newton per mm square, so it will come 200 into e to the power 200 into 10 to the power 3. So we can write it as 200 into 10 to the power 3 means 3 more zeros, and Poisson ratio was 0.3. Okay, now we'll click on the OK button. After this we'll close this one. After assigning the material, we assign the linear isotropic properties of the material and we'll close it as. After closing it, now we'll close material properties and we'll go to the meshing part. We have assigned the material properties. Now we'll go to meshing part. Click on the meshing, go to mesh control, size control, manual size, area, then all area, and size. They are asking the edge length. What was the edge length they have given? Edge length we have taken as 2 mm. Okay, so we will write the edge length as 2 mm and we'll click on OK. Okay, now we'll go to area mesh. We'll minimize this one, area. Okay, go to mesh, minimize this one. Okay, click on the mesh, go to area, then click on free because we want to do the free meshing. Okay, in the free surfaces. Okay, so now after clicking here, see, we first what we did in the size control, we assigned the thickness like edge length. Okay, then mesh area, we clicked on the area, mesh area, and then free, and then we'll click the pick all because we want to do the meshing on all the parts. So we will click pick all option, pick all options, so it will complete the meshing in all the areas. So see, we can see the edge length of having edge length of 20 mm, and actually meshing edge length was 2 mm. So using 2 mm we have created the meshing here. Okay, now we will minimize all this. We have created the meshing part. Now we have assigned the material, we have given the element, we have given the young modulus. Now we will go to the solution, because now we'll do the solution part. We'll apply the load, we'll define the load, we'll apply the load at the center. Okay, we'll define the load, click on the apply button because we want to apply the load, and load is the structural, on the structure we are applying the load. So click on the structural, then go to online. We want to apply the load on area, right? So we'll click on the nodes. We will apply the load on the nodes. So we'll click on apply nodes. We will click on the displacement and on the displacement on node, on not this one, on node. Okay, and after this we'll go to circle because we want to make node here on the circle, on this circle we want to make node, right? So we will click on the circle and we'll go to plot control. Pan zoom rotate option will be there. We'll click on this. Then we'll click on the box zoom. It means like we will make a box and it will zoom that part of the model of the bracket, and it will show us the zoomed view of this one. Okay, so that we can assign. Okay, so here we can see they have given the zoom view of that part which I have underlined, like which I have made inside the rectangle. Okay, so after making this, after zooming, we will make the nodes. We will make the different nodes on the base, on the periphery of the circle. Okay, so here I will take on the center, left click, and I will go like this. Okay, wait, from here go to center and touch the circle. Okay, like this. Okay, so here we have created the nodes. Okay, after this, after creating the nodes on the periphery, on the circle periphery on of this hole, we'll click on the OK button. Apply. We'll click on apply because we now after like these two holes will be fixed. So we want that the degree of freedom to be constant. We don't want that this part should be moved. Okay, so we will constant all the degree of freedom, so it will not move in any direction, so it will be constant, all the degree of freedom will be constant. You click on the OK button. So here you can see like we have created the nodes. Okay, okay, now again we will go to again we want to go back to our back model, like this is the zoomed view, right? Again we want to see our actual model. We will go to pan zoom rotate. Again there will be option called fit. There will be option fit. On we will click on the fit option, so it will show our actual model whatever was available. Now again we will do the same operation for the our second smaller hole. Okay, again we will click on the box zoom. We'll make a box and we'll make a box. We will press a left click and we'll drag it up to here where up to we want to zoom, and we'll leave the button, so it will give us the zoomed view. Now we want to make the nodes on this the periphery of the circle again. So making the nodes, we'll click on node. For making nodes, we'll click on node. Okay, now circle. After clicking circle, we will take our cursor in the middle, like assuming it as a center, like somewhat it should be like center. If it is not like, and we will try to touch the periphery of the circle. Okay, so we here see here we have created one extra node which is not on the periphery, on the circle, on the circle periphery. Okay, this is like extra one, so we want to unpick this one. So click on unpick and click on the single unpick because we want to unpick single node, and click on this one. So this will be this node which was extra like on the surface and it was not on the periphery of the circle, it will be get removed. Okay, now after this we'll click OK options, either OK or apply. After unpicking, if any extra nodes we have created, then we'll click on OK. We'll remove that one using unpick option. Okay, now click on OK. Now here also we want to constant all the degree of freedom. We don't want that this hole should move, this two holes should be fixed, so we will constant all degree of freedom. We'll click OK. So here we can see that all the node like this whole full circular part is constant. Okay, this cannot be moved in any direction, neither x neither y. Now again we want to see our full view of the model. We'll go to plot control, pan zoom rotate, and we'll click on the fit option. It will give the full view of the model. Okay, now after this, see we have created the nodes on the periphery of this two circle, right? Now we want to apply the forces. For applying the forces, we'll go to force option, we'll minimize this one, we'll go to force. Okay, after force we will apply the force on the nodes, okay, right? So we have to apply the force here on the center somewhere. Okay, so we will select one node here, we'll click on node option, on node. Okay, and we will click somewhere here, a node here. Okay, and after that we'll click OK option. So here they are asking the direction of force. Direction of force will be in the y direction, and since we are applying the force in downward direction 1000 Newton, so we will write the value as in minus negative, because we are applying the load in negative y direction. So right, the magnitude is 1000 Newton, but we are applying the force in negative direction, so we will mention the value as minus 1000, okay, Newton. We don't have to mention the unit, because it is will always take in the SI unit, right? So we have written minus 1000. Now we will click the OK button. So force will be applied. We can see the force has been applied. We can see the force has been applied in the minus y direction, whose magnitude is 1000 Newton. Okay. After this, we have applied the force. We have created the make the node. We have make the meshing everything. Now we will go to solution part, because we want to solve this. Now we want to solve this. Okay. Okay, so we'll close this one, structural, apply, define load, we'll minimize all this. Again we will go to solve. Okay, and after that we want to solve this one, so click on the current ls. So here they are asking solve, begin solve of for current load step. Okay, we'll click on the OK button. So here they will show a bar called solution is solved, solution is done. Okay, this means this is indicating that solution is done without any error. Okay, now click on close, click on this close. Okay, now we want to see the what are the contours and plot. So go to general post processing. Want to go to general post processing. Here we will see the plot results and contour result. Okay, so we'll go to plot result, go to deformed shape, and here we want to deform and undeformed shape. Click on the deformed and undeformed edges. Okay, so here we will see the deformed and undeformed part. Okay, now click on OK. So here we can see the deformed part. Here this is undeformed part, because this was completely fixed, all the degree of freedom was constant. Here is the deformed part, because this part, this node is, this nodes on the periphery of the circle was not fixed. So when the load is applied in a downward y direction, so this is got deformed. Okay, now we want to do the contour plot. Okay, now we will select in the contour plot. After contour plot, we want to see the nodal solution. We'll do the nodal solution. Click on the nodal solution. Then here we want to whatever we want to see, we'll click on this and they will show us the contour of the result. Okay, so first we will see the degree of freedom of the solution. Okay, here we can see the x component of displacement, y component of displacement, then displacement vector sum. Displacement vector sum will show completely the displacement. Okay, we'll click on this and we will click on OK button. So it will show us the displacement in complete displacement. Okay, so this is the complete displacement. Now again we will click, again we want to, let's see, we want to see the stresses. So again we will click on the nodal solution, we'll click on the stress, we want to see one stress, one miss stresses. So we'll go to one miss stresses, and here we will click OK. So it will show us the one miss stresses. Let's see, we want to see the stresses in x component stresses, so we'll click on OK. And or we want to see the degree of freedom in x component of displacement, so we'll click on OK. So it will show the in x component displacement, how much displacement is there. Okay, now after this, so this was the like complete video, like how to see the stresses and how to see the displacement of the bracket having two holes which was fixed, and in this bigger hole in which load was applied in the negative y direction of 1000 Newton. So like this we can see the different nodal solution. Let's see, we want to see the y component displacement, we'll click on y component displacement, we'll click on OK. So it will show us the y component displacement. Red area means so much displacement in y direction is there here. and like blue color means very less value, like it is around 0.00367. Okay, and for negative, for red part, it is the value is minus 236 into 10 to the power 3. It's a very large value actually. Okay. So we'll can see the total, we'll see the again vector sum. Here we can see the values, like total red area, this area, like so much displacement is there in this part, whose value is 0.003236. And here in this blue area, displacement is very less because it is completely constant part. Okay, and here it's just like it is more exactly zero, like no displacement is there. So like this we have done the analysis of the bracket which was given to us. Like we have done the structural analysis of the triangular element in ANSYS APDL software. So please like, do share and comment to the video, and if you like the video, please comment it and subscribe to my channel. Thank you.